The half-life is the time it takes to eliminate 1/2 of the dosage. So when you take a drug, a lot of the what goes into, in other words, how far apart you take the drug over the course of the day, is based on the half-life. So the elimination of 1/2 of the dosage that you've taken. A couple things to note about this is that water-soluble drugs, or drugs that you eliminate via urination and are broken down in that matter, typically have shorter half-lives. Again, this is what this determines is the duration of action. It does not change with the individual dosing of the drug. So what this will actually determine and look at is how long the drug works and how often you are going to be looking to take an individual drug. The idea of tolerance to a drug is another response that could happen, and what this basically is a diminished response from a drug due to continued use. So it's basically from constantly utilizing the drug, your body develops a way to kind of limit the effects you can get from it. A couple things to point out: not all drugs do produce tolerance, and it occurs via two mechanisms, which we're going to discuss on the next slide. So tolerance occurs by two mechanisms. One is by liver induction, where the liver actually produces more enzymes that cause a decreased effect. One of the ways in which you could actually see this is with actually alcohol. Is a common way of this, and people who tend to drink more alcohol tend to not get the same effect or get intoxicated quite as readily as someone who does not. Where what happens with the continued chronic use of alcohol, the liver will produce more enzymes to basically reduce the effect that alcohol has on the body. Now, obviously, there's other health ramifications to chronic alcohol use and abuse, but that's a common example as to how that occurs. Another way you can get tolerance is through what's called receptor effects, where you either get a decrease in the number of receptors to the drugs or a decrease in the affinity or the ability of the drug to have that lock and key relationship with the receptor. So those are the two different ways that you can basically get tolerance. And you could also get something called cross tolerance, where drugs, even within a common category, maybe not necessarily the same drug, but a drug that is within the same category, will actually produce tolerance with the body as well. Some other effects, and again, this kind of looks at how we repeatedly will take a drug when we've been prescribed something or taking a drug to treat something, or the concept of multiple doses in steady state. As you take a drug, obviously the concentration in the blood gradually increases. So the point at which the concentration slows down is basically the steady state. So that basically tells you once you have a certain concentration of the drug in the body, that will be the steady state. And usually what they say is it's greater than 4 times the half-life, which we sort of talked about a little bit already, but we're going to mention a little bit more in the pharmacokinetics portion of the discussion. So 4 times the half-life of the drug is the point at which the concentration of the drug will kind of reach that steady state. So that's part of the reason why a lot of times, it's important to make sure that you're taking the drugs, at appropriate intervals and taking it for the specific period of time that it's prescribed, because that's how the drug will start to have a lot of its particular effects. The only way to basically increase the steady state concentration is 2 mechanisms. You either increase the dose of the drug, or you decrease the dosing interval. So you basically, each individual dose increases, or you decrease the interval time in which the drug gets taken. Adverse reactions are kind of the unintended consequences of taking a drug. Obviously, anytime you put something in your body, there's a risk. When you look at different types of drugs, you will typically have different types of adverse reactions. A local reaction is when it's contained to a particular site. This is most commonly seen with your topical drugs, your creams and things like that you would rub on the skin. Basically, what you would see with a lot of those are very, very localized skin reactions. Your more systemic effects, or your more generalized effects, which typically happen in an acute fashion, will happen more with your systemic drugs. And I have some examples here. Your NSAIDs can cause hypersensitivity in individuals who have asthma, which can basically predispose people to an asthma attack if they have that hypersensitivity, or they can be delayed. And actually, a very common thing to happen because people take too much of it is with acetaminophen or your Tylenol is the hepatotoxicity. Tylenol, if taken in high dosages inappropriately, can predispose people to damaged liver.